There we go.
The coffee.
What's that?
Who's going to do the group coffee?
I can do it.
Okay.
I can submit it if you guys want.
Go for it.
So answer the following questions as a group, and the group leader will submit one copy for the group. Make sure to submit the group quiz as a single PDF document. You may only use your textbook notes and calculator on these problems. You may not use any outside resources, including the internet, tutors, or calculator, or solution manuals. Whoops. I can't use a calculator. Remember that the purpose of the quiz is to see if you understand what you have learned on your homework and to also tell you what you still need to study for the upcoming exam. Make sure to show your work in a neat and organized manner. A correct answer without supporting work will not receive full credit. Okay, number 1. You want to swim from one side of a river to another. Assume your speed is 3 miles per hour in the west direction with negligible water velocity. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is your resultant speed and direction? Hint, it may help you to draw a picture. So let's draw a picture.
It's going a little bit faster north than you are going west. So you're probably going to be a little past 45 degrees up, right?
Yeah. So 3. At a certain point, so that's 3, and at a certain point, there's a current. And that's 6 miles, 6.2 miles per hour in the north direction.
Is this like vector problem then?
Sounds like it.
Attitude and direction.
Yeah. So the vectors would be 3, 0, 0, 6.2.
It'd be 3, 6.6.
No, like individual vectors, because he's so like he's swimming at 3 miles per hour in the west direction, which I think I drew it east. Whoops. And then the river is flowing 6.2 miles per hour north. So then
Yeah. He doesn't encounter it until, I guess, yeah, never mind.
I have to redraw my picture because it's not going east.
You draw it on a Cartesian coordinate system. I don't know if it makes a difference, but if you're going west, that would be -3. But
Yeah.
what's kind of confusing me is that he's not counting.
Is he's not what? Encountering it right away?
Yeah.
Yeah. Well, let's read the problem. When you reach a certain point, what is your resultant speed and direction?
I guess, yeah, we could probably just use 3, 0, and 0, 6.2.
That's still on Cartesian. Put it on a graph. Because it would just be that, like, for the first little bit, his velocity and direction are west and 3 miles per hour. Well, when I think it only matters, I think it's only asking when he encounters the water flow. What is that direction and velocity? Unless they wanted to like, take the 3 miles per hour and west and the other one and then average those together. He doesn't encounter it right away. I don't know.
So our vectors would just be, wouldn't it just be 3, 6.2?
Yeah. Do we want to use -3 or?
For magnitude, it's squared anyway, but it probably would be -3 if we're going west.
Okay. 3, 0. And then 6.2. -3, 0, 6.2, 0 and 6.2. So then, yeah, the resultant vector would just be -3, 6.2, wouldn't it?
Yeah.
And then for the velocity, square root of -3 squared plus 6 squared equals the square root of 9 plus 36 square root of 45. Do they want an exact answer, or does it matter? Probably, right?
Yeah.
So, tell me if I'm wrong. I got direction is 115.8 degrees.
For direction?
Yeah. I don't know if that's
115.8 degrees. Oh, for the angle?
Yeah.
yeah. I don't know if that's right though.
Let me see.
That's what we're just using that vector of -3 and 6.2.
Oops. Yeah, I got 115.8.
Yeah,
Yep.
that's what I got. So,
So the magnitude is square root of 45. Which is 6.7.
.9.
You did?
Yeah, because it's magnitude is square root of u1 squared plus u2 squared. And since it's 6.2, it made it a little over 45. Made it.
Oh, yeah. I'm an idiot. Yeah, 6.2.
Yeah. With a square root of 47.4. I got 6.9 miles per hour.
Yeah.
38.44. 47.44.
Yeah.
What am I going to do without you guys?
I'm never taking another math class after this. So.
Yeah, I hope this is my last one. I'm done with that.
You tell me I need another math class.
I have calculus and then multivariable calculus the next, and I have physics, and I have thermodynamics and statics, all this good stuff to look forward to.
Well, you have fun with it.
Luckily, I like this stuff, but I don't know how much I'm going to like it when I'm done.
I don't need to be a.
What?
If I go the PA route, I don't need to be March. That's right.
Yeah. So 6.9, and then just let me do the work for the angle.
Okay. So yeah, I just drew a Cartesian coordinate system, and it plotted -3, 6.2, and drew a triangle there.
Yeah.
The x-axis. Use the tangent system, the inverse tangent of 6.2 over 3. And that gave me -64 something, and then I just added what to it.
The tangent of theta equals 6.2 over 3.
-3.
-3.
Or that works too. Yeah.
Oh, no, it's just 3 because it's just the length of the side.
Yeah.
So the theta equals the inverse tangent of 6.2 over 3. 6.2 divided by 3. The inverse tangent of 2.066 Blah, blah, blah. So 64.179 180 degrees minus 64.179 equals 115.8 degrees. So, what is your resultant speed and direction? Technically, that'd be like north 25 degrees west,
Yeah.
25.8 degrees west or something. I don't know if they want us to write it like that, or if you can just say 115 degrees.
So
Right.
it says, yeah. I don't know how they want to do it.
Okay, cool. Number 2. Everybody good with that?
Yeah, I hate
So-
number 2. I don't like
The
that.
answer for number 1 is 6.9 miles per hour at north 25.8 degrees west.
Mhm.
Because I feel like if you just said 115 degrees, it'd be like 115 degrees from what? You know?
Yeah.
So, number 2 is stupid.
Yeah, I hate this question.
Right equivalent rectangular equation for the polar equation. Yeah, I hate this stuff. I was doing this in the last night's homework, and I was like, "What?"
Yeah. I gotta find that again on my note.
Do you get it, Julia? Please tell me you do.
Kind of. It's more like I find patterns, because like math, there's just a ton of patterns. So all I know is that like sine is like the y coordinate. Or like sine goes to y and then cosine goes to x. And so like in the equation it would be like 7x and then 3y
Okay.
and then somewhere 10 goes in there. But on
So
the x, so
we could take the bottom and multiply it by r, and we could just do 3x minus 7y, or no?
let me find it in the book again just so that I can like see it.
Yeah, I'm trying to find out my notes again. Sure where it's at. Yeah, so cosine is x over r, sine is y over r.
Wait, what?
So x is equal to r times cosine, and y is equal to r times sine.
Yeah.
So we can do a lot of substitution and stuff. Hard to get.
So isn't it like r equals x over r or something? I don't know. Well,
Yeah, r equals x over cosine, and r equals y over sine.
r equals x over cosine.
Yeah, and or y over sine. So we could do r equals 10 over 3 times y over r minus 7 times x over r.
So sine 3 sine of theta is 3 x over y over r.
3 times y over r.
Okay.
That sounded right, Julia?
I was occupied finding it in the book and I found it, so I was not listening to the last minute.
That's
Sorry.
okay.
That's all good. So the equivalent to it, so where we're at is like r equals 10 over 3 times y over r minus 7 x over r. And we can take that out, bottom by multiplying. So we got r 3 minus x over r.
Is that conducive to what you found in the book, Julia?
Possibly. It could just be like a different way because I'm just looking at one solution.
So we brought it over to the other side, so we got 3r times y over r and 7r times x over r. Right?
Yeah.
3r times y over r minus 7r times
Or d,
was 10. So then that'd be 3ry over r minus 7rx over r equals 10.
when the r cancel those out.
Mhm. So then you'd have,
R cancel the r.
yeah,
So you have like 3y
3y minus 7x
minus 7x.
equals 10.
Yeah.
So then 3y
I don't know.
equals, if you add 7x to both sides, because I think you have to write it in terms of y. 3y equals 10 plus 7x. And then
Y equals 7, 3.
divide everything by 3.
And you just substitute that equation.
Y equals 10 thirds plus 7x, or 10 plus 7x over 3.
Yeah. That's what I got.
And that's it, right? That's the whole enchilada.
Yeah.
Wait, what is it?
Y equals 10 plus 7x over 3.
That's the answer?
Yeah, I think so.
That's what I got.
Like 10 plus 7x all over 3.
Yeah.
Yep. That's what I got.
That's what I got.
Oh, that's cool.
Did you get that, Callum?
Yeah, that is.
I don't think we have to do anything else with that.
Nope.
For some reason, I was thinking we could put it into like coordinates,
Nope.
but we don't. So that's nice.
Okay, number 3, write an equivalent polar equation for the rectangular equation x squared plus y squared equals 9 times y over x squared. Jeez, kill me.
Oh, don't worry. Just take out all the square roots and it's a lot easier.
Yeah.
Kind of.
Yeah. So I'm going to pretend like my phone quit working, and then I'll come back and you guys have this question.
Okay.
What?
So,
I said I'm going to pretend like my phone quit working, and then I'll come back and you guys have this question done.
Yeah.
go.
Gotta go for a second. Coda.
So we just like take this whole equation and put it in square root. Square root of it. Take away the.
I just got rid of the square root.
Okay. It's just x plus y. 9 y over x.
Yeah. Well, 3.
3
It's
y
also
over x.
square root the 9, so it's square root of 9 is 3.
3 y over x. So x is equal to r cosine and y is equal to r sine. So
Yes.
r cosine plus y sine 3, or r sine, sorry. 3 r sine over r cosine. R. Right?
I think so.
What do we take? Let's see.
So, did you get an answer yet? Did you get an answer?
For the whole equation?
Yeah. Like, what did you end
No.
up?
Well, so you have to take like the r sine over r cosine and get the other side, and then you just r out of the equation.
Yeah.
Take r out, but factor it out. Factor out. How do we do that? It's like multiply both sign and then divide by 9.
Stay. Come, Coda.
So Callum, for the final answer, did you get that r equals 3 sine over 3 cosine?
No, I kind of got confused on how to do it. Like how did you get r sine over r cosine over the other side? What was your equation for
So
whatever?
in the book, it says that like where'd it go? It says that x squared plus y squared equals to r squared. So I was just kind of using like all these different things. Like I was using these conversion factors, I guess you can say, to help. So it's x squared plus y squared equals r squared. X equals r cosine, and then y equals r sine. So
yeah.
So then what I did was, since we have x squared plus y squared, I just converted that to r squared equals 9 over yx squared. So then I took the square root of all the whole equation. So then r equals 3y over x.
Okay.
I guess I should feel like it's 3r sine over 3r cosine. Yeah.
I'm confused.
Because then the y goes to r cosine and x goes to r cosine. So then putting that into our equation, 3 by our cosine, and our sine, obviously, multiply it all together. That makes
R out of How'd you get R out of the right side? You just
well, you can,
So-
since being all multiplied, it's 3 times R times sine, and then 3 times R cosine. So you can take R out and do like 3 sine over 3 cosine times R, and then you can divide R by R, which is technically 1, so it's still R.
okay.
So x equals r times the cosine of an angle, and y equals r times the x equals cosine, and y equals r times the sine of an angle.
Yeah.
And then you just like factored out r.
Yeah.
R times the cosine plus the sine.
Not plus. The whole thing's being either multiplied or divided.
But it's x squared plus y squared.
So x squared plus y squared equals R squared.
Equals, yeah.
Equals what?
R squared.
R squared.
How does that work?
It's one of the conversion things in the textbook.
Oh, really?
Yeah, like there.
Oh, yeah. Duh.
We use the relationships
Right, I'm
x
sorry.
squared plus R squared, and then x equals R cosine, y equals R sine.
Right, x squared plus y squared equals r squared. So r squared, square root of r squared equals the square root of 9 times y over x squared. So r equals 3 times sine of theta over cosine of theta. Right?
Yeah. Yeah.
Is that it then?
No, because you got to factor out R.
Oh. If there's r on top and bottom, then that just cancels out, doesn't it?
Yeah.
That would
Well,
just
not.
1.
Yeah.
Like no matter if it's like x over x and x equals 5, that's just going to end up being 1 anyways. It's not x anymore, right? So r over r is just going to be 1.
Yeah, so it's just equals 3 times sine over cosine.
I really hope I'm...
3 sine over cosine.
Yeah.
Yeah, that's what it is. So R equals 3 sine over cosine.
Okay. Number 4.
Graph the polar coordinates 4 pi over 3 or pair. Polar coordinate thing. Point over the coordinates and 2 other polar coordinates that are located in the same place as 4.
We can draw a graph. 1, 2, 3, 4. And a circle. It's a really bad circle.
Yeah, I drew a clever one too.
4 pi over 3 is going to be
120 degrees.
240 degrees.
240 degrees. Yeah. So another point would be -4. Uh, 300 degrees.
-4, 300. You said?
Yeah. All right, because when you have a negative radius, it goes clockwise.
Oh yeah, 300 degrees. Which 300 degrees would be?
All right. That's wrong. That's wrong.
No, it'd still go the other way.
Is it?
It would still go counterclockwise. It'd go clockwise if it was negative something. So that's probably the other one.
Okay. Yeah, that's right. It was like negative 120 degrees.
So for -4, it'd be, yeah, negative, or not negative. Just be 60 degrees.
Yeah, -4 is 60 degrees.
Pi over 3. -4 pi over 3. And then
Or
for negative 120 degrees. So 2 pi over 3.
Yeah. That sound right, Julia?
Sounds right.
Cool.
Okay. Sweet. Well done, everybody. Sorry I had to leave for a second. My dog's being a brat. What?
You're good. Time to go bomb the test tonight.
Yep.
Yep.
Good luck in the game.
Take the exam. Good luck.
All right,
Thanks.
y'all. Yeah.
Okay.
You guys.
Bye.